All right, today we are talking about irrational numbers. If you are looking at the interactive notebook, you would use pages 14 is where we are starting. So a couple things with this would be like 1.2. Has anybody ever heard of rational or irrational numbers? Okay, a rational number is going to be a number that stops. Another word for stops is we say terminates. Or repeats. An example of a rational number would be any number that stops or repeats. Does anybody have an example they would like to share with us? Good. An irrational number with an I is going to be the opposite of a rational number. So an irrational number is a number that does not stop or terminate and does not repeat. Can anybody think of an example of a rational number? I'm sorry, an irrational number with an I. All right, to write a couple examples down for rational numbers, that'd be like 3, 5, 1/2. All fractions are rational. What about 2.83? Do we think that's rational or irrational? All right, 2.83 is going to be rational with an R because it does stop. Let's look at some examples of irrational numbers. Does anybody have one they'd like to share? Most of the time, you're going to see these irrational numbers in square root form. So an example of that would be like the square root of 11. If you put the square root of 11 in your calculator, it's going to come out to 3 and then has a lot of numbers. So that's an example of an irrational number, square root of 11. Another example would be 5.2832 ... Remember, this ... means it's going to go on forever. So for this example here, this number does not stop because it got the ... and it does not repeat. The first thing we're going to look at is example, the try it on page 14. It says Jen classifies the number 4.567 as irrational because it does not repeat. So 4.567. Jen, the student, says that that is irrational with an I because it does not repeat. Do we think Jen is correct? No, Jen is not correct. Why is she not correct? Because even though it does not repeat, it does stop. It terminates right here. There's no other numbers. We don't see ... So we're going to say no, it is rational because it stops. Remember now, if to be rational, it could stop or repeat. So even though this does not repeat, it does stop. Can anybody think of an example of one that repeats? An example I have would be like 4.555 and so forth. If we want it to go on forever, we're going to put the dot, dot, dot. So that would mean the 5 is repeating here. This would also be irrational. Rational because it repeats. Another way that you're going to see this, and it's more of a shortcut, instead of writing 4 point and then continuously write 5s, would be 4.5, and then you put what's called a bar, B-A-R, a bar above it. That means it repeats. So if you ever see a bar, that means it's going to be rational no matter what, because it repeats. The next example, this is going to be on page 15. It says classify the square root of 3. So on Desmos, on your calculator there, put the square root of 3 in the calculator and tell me what it equals. All right, when we see that in our calculator, we look at it and we can tell that it does not stop and does not repeat. It goes on forever. The square root of 3 would be irrational. We're going to have a few that we're going to look at on our own here. Let's just make this, we'll make it right here in brown. Okay, go ahead and write those ones down and then classify those as rational or irrational numbers. Make sure we're able to explain why they are rational or irrational. Okay, for the first one, that's going to be rational. What does it do? It stops or terminates. Second one is irrational. Does not stop or repeat. It does not do either. Third one, rational. Third one was going to be irrational. Same reason, does not stop or repeat. And the last one, if we put the square root of 16 in our calculator on Desmos, or if you have your separate calculator in hand, the square root of 16 equals 4. So then you have to ask yourself, is 4 a rational number? Of course it is. It stops. All right, so when we look at all these different examples, do we think there are more rational numbers or irrational numbers? Okay, moving on. Good. We'll look at a couple more examples just so we have some before you guys get to your homework. I will do those in blue up here. Let's look at 2/3. Is 2/3 going to be rational or irrational? Good. It's going to be irrational because it's a fraction. Remember what we wrote down up top there was all fractions are rational. Square root of 25. All right, when we find the square root of 25 in our calculator, that equals 5, which makes it rational because it stops. Negative 0.75 with the 5 repeating. Remember that bar means it's repeating. It's going to be rational because it repeats. Square root of 2. Go ahead and put the square root of 2 on your calculators. When you do that, you'll see it's going to be 1 point in a long list of numbers. It's irrational then. Does not stop, does not repeat. Finally, does anybody know what that number is? Can we say that number? Because it's going to be 7,548,123. That is going to be rational because it stops. Even though it's a long number, it still stops, making it rational. That's kind of the conclusion of rational and irrational numbers. What we are going to do is look at a couple more examples. These are going to be on 16 and 17, page 16 and 17 of your student workbook. Remember, we can always find that on Pearson. One question, how can you tell whether a square root of a whole number is rational or irrational? We're just using our calculator. When we put it in our calculator, if it comes out to a number that does not repeat and does not stop, it's rational. A few more examples here. I'll pick a different color, make it stand out a little bit. This will be number 10. All right, and the question asks us to find out which one of these is irrational. So we look right here, we see the bar. What does that bar mean? Okay, good. That means it repeats. So those two numbers are going to repeat. So therefore, it's a rational number. A fraction is rational. Square root of 15, when we put that in the calculator, it equals 3 point, and it goes on forever. Square root of 100 equals 10. So our irrational number is going to be right here, the one that does not repeat, does not stop. There's a couple more of these we could do in person together. And we'll take some time to ask any questions. If you have anything you need to add, let's go ahead and get that out of the way now. And then you'll have some time to work on your assignment, which is another Google form.